Mecca, Saudi Arabia. So, as known about Saudi Arabia, the economy of Saudi relies on oil for the majority of the export and revenue. But in 2016, the government established a new vision that aimed to change the country's path to become more sustainable and to reduce the reliance on fossil fuel, and also to find alternative source of energy. So, according to Amin Nasser, the CEO of the leading oil company in the world, Aramco, he mentioned in the Saudi Investment Initiative conference a few weeks ago that the climate change related issue is the main concern of the vision, and reducing the carbon footprint is a priority. So me as an architect, I have a great responsibility to be part of this vision, since buildings account for the majority of the energy consumption and also produce a huge amount of CO2 production. So a brief highlighted about the energy in Saudi Arabia. According to the Energy Information Administration, Saudi Arabia was ranked #1 energy nation, consuming energy nation in the Middle East, and #11 in the world. So the availability of oil create a lack of awareness from people in Saudi Arabia about the importance of sustainability or about the importance of their energy consumption. So leading the country to become the second largest country in terms of energy consumption per capita. So the huge energy consumption lead the country to be one of the highest producer of the CO2 emission in the atmosphere. So my project went through 3 different phases. The first phase was an interview with the architect of the Ministry of Education, who talked about the intention of the government to enhance their building as part of the vision. So I went to different schools, I took some pictures, I collected some data about the schools, then I implemented and applied all the data that I collected to the eco-simulation result to simulate the existing situation and to find the deficiencies, where the deficiencies are. So after found the deficiencies, I applied the different passive and active strategies and PV plans to achieve net zero energy. So before I start talking about my project, a brief introduction about the net zero, or why is it important and how is it related to my thesis or related to the vision. So the basic definition of net zero energy is the building produces as much energy as it consumes or more, meaning all the appliances or all the mechanical system in the building can be generated by an on-site renewable energy. How is it related to my thesis, or how is it related to the vision, is that in net zero energy, building consume less energy, resulting to a less production of CO2 emission, and also reduce the reliance on fossil fuel, and most importantly, protect the environment for the new generation. So how do we achieve net zero? Through maximize the use of natural sources to create a comfortable condition inside the space, enhance the efficiency of the system and appliances in the building, and lastly, the remaining need of energy can be generated by on-site renewable energy. The goal of my research is to demonstrate that net zero energy schools are attainable in Saudi Arabia, provide direction through recommendations, strategies and solutions for achieving net zero energy in our region, and also create an education icon that can be applied not only for schools or not only for government building, it also can be applied for different sectors such as commercial sectors, residential sectors as well. So moving forward to my building or my case study, so I've chosen a four-story primary school building that located in Mecca city. The reason for choosing this specific city because it's a high-density city. The school can be exposed to 100,000 people from all over the world. They come for Mecca, so the school can be an education icon that educate the people from all over the world about the appropriate design for hot arid region. Another reason is that Mecca has a hot arid climate, which represents most of the climate condition of the occupied cities in Mecca city. So after implementing all the data to the eco-simulation result, the data from equus shows that most of the energy consumption goes to the cooling load and lighting load, and cooling load is the highest, which is obvious because the building located in a hot or in a harsh climate. So in order to achieve net zero, a critical step is that to demonstrate the energy use intensity, which is a comparison of a building as a prototype with other buildings that have the same characteristics or the same area. So the energy use intensity can be calculated by dividing the energy consumption of the building by the gross area, and the lower the energy use intensity, that needed to be implemented to achieve net zero. So as you can see, my building is worse than the typical design standard. It should be minimized to be in a net zero energy building so that we can achieve net zero. So some of the deficiencies that I analyzed after visiting the site and after interviewing the architect of the school and also from the eco-simulation results, one of the deficiencies is the excessive use of HVAC system, especially in the atrium. As you can see, there are over than 10 HVAC systems that account for 20% of the cooling load consumption, which is an area that it's not used. Also, as you can see, blocking all the windows, preventing the daylight from entering the space. Also using an artificial light in an area that can be provided with daylight. Also, as you can see, the waffle-shaped ceiling that doesn't help distributing the light correctly. And one of the major problem or major deficiency that a building have is the window type, the single pane window type. The building have over than 200 windows, and the window is a major source of heat gain and increase the discomfort inside the space, and also increase the need of cooling load. Also, the lack of shading devices, especially in the east and west facade. Since the east and west receives an excessive solar radiation, also even the shading device or the overhang that located in the south it's not designed appropriately, which allows the direct solar radiation to enter the space during the overheated period or during the day. A major deficiency, which is the insulation, the lack of insulation, and this is a problem that in most of the buildings in Saudi Arabia, we have a lack of insulation, which roof and wall account for 25% of the heating, for the heat gain and loss in the building, so insulating them is essential. The high window to wall ratio in the east and west facade, even though in the hot arid climate it's very important to have opening for natural ventilation, but it's also a major source of heat gain and should be minimized. So in order to achieve net zero, I implemented different passive and active strategies and to enhance the performance of the building before applying PV panels to achieve net zero, starting with the passive design or the passive strategies, or the passive design uses the climate outside to maintain thermal comfort inside the space, so it reduces or eliminates the need for artificial light or mechanical system to cool down or to lighten the space. So I implemented different passive strategies, including shading devices, insulation, changing the window type, and night push ventilation, which I'm going to be explaining a bit. Starting with the roof and wall insulation, so I added a 4 inches insulation to the exterior wall with the R value 21, and also 33 inches insulation to the roof, which according to the eco-simulation result that can decrease the energy consumption of the building by 6%. Also, as I mentioned, a major deficiency was the window type, so I replaced all the windows with a double low E window. Windows, the low E meaning that heat passes through, least heat passes through the glass, and the double glazing, it's a 2 sheet of glaze with the argon gas in between that reduce the flow of heat. And why is it important to replace the windows in the building? It can reduce the solar heat gain, increase the lighting, reduce the cooling and lighting load, and improve the human thermal comfort inside the space. So according to the eco-simulation result, this strategy will reduce the energy consumption by 2% from the cooling load. And as I mentioned earlier, that the light shield, the overhang that located in the south facade didn't design appropriately. So as you can see, there is solar radiation that entering the space during the summer, since the south facade is the best or the perfect facade for daylight, so I implemented light shield, which diffuse the light deeper inside the space, providing daylight to the space, and also at the same time preventing direct solar radiation from entering the space from the lower windows. But also at the same time, it allows the solar heat gain to enter the space when the temperature is cooler. So this is the light shelf, works as an overhang to the lower window, and due to the depth of the window, there is no need to use an overhang to the upper window, and also there is no need to use a vertical beam because I extended the overhang to all windows. another major problem that I had was the lack of shading devices in the east and west facade. So to fully shade the windows in the east and west facade, the view will be compromised unless using an extensive overhang. So in order to avoid that, double screen facade will be appropriate for the east and west facade. So I implemented a mashrabiyya, which is an Islamic pattern that represents the vernacular architecture of the area. It's used as a double screen to the east and west facade, and it can obtain 5 performance strategies. It can prevent solar radiation, minimize the hot air, and also control airflow, introduce sunlight into the space, and also maintain the privacy of the space. Since buildings or school building in Saudi Arabia, we have a female building and a male building, so it can maintain the privacy for the females buildings. So the pattern that I used was already used in King Abdulaziz University in Jeddah. So according to or based on the eco-simulation results, implementing shading devices and daylight to the space can reduce the energy consumption by 25%. So another strategy is the night purge ventilation, which is an ideal strategy for the space cooling. Space cooling strategies that can reduce or save energy and can enhance the air quality and also increase or improve the satisfaction of students inside the space. It works the most when the daily range temperature is 20 Fahrenheit. So for Makkah situation, the daily range temperature is between 17 to 23. So it works by and it works the most also, or some of the principles that should be considered in the night purge ventilation is that the thermal mass should be exposed to easily absorb the heat that's released from students and other internal or mechanical loads. Also, the heat gain should be minimized by implementing shading devices or insulation. So the night purge ventilation work when thermal mass absorb the heat from students and other internal loads during the day, then it release it to the indoor air when the temperature is cooler. Then the upper window should be open for setup of time to allow the heat to escape from the building. So after enhancing the performance of the building passively, and reduce the heat gain that entering the space, the need of HVAC system will be reduced. So since since each class has 2 HVAC systems, and the need of the HVAC system is just one, so we can just use one of the HVAC system and leave the other one for urgent situations. This strategy will reduce the energy consumption by 12%. So after implementing all the passive strategies to the building, we reduce the energy consumption by 48%, leading the building to become a high-performance building. But still, we need to we'll reduce it more to be in a net zero so that we can achieve net zero building. So active strategies or enhancing the mechanical or electrical building in the electrical system in the building. It's crucial to enhance the building even more, to enhance the performance of the building even more. So starting with the high severe HVAC system. So after using just one HVAC system in the classes instead of 2, then we can replace the HVAC system with more efficient one that consume less energy, which can reduce the energy consumption by 11%. Also, another thing is the artificial light. As I mentioned earlier, there was an excessive use of artificial light, and the reason for that was using the tint on all of the windows and just blocking all the light from entering the space. And since the school it's during the daytime, so there is an opportunity to have daylight. So after implementing the passive strategies that provide daylight into the space, we can reduce the need of artificial light, and also the remaining artificial light that we have in the space on the building, we can replace it with a more efficient artificial light that consume less energy, the LED light, which can reduce the energy consumption by 15%. So, the total reduction from the passive and active strategies is 68%, leading the building to become a net zero energy building. So after that, the remaining energy that needed from the building, which is a 260,000 kilowatt per hour, that can be generated by an on-site PV panels, 263 panels located in the roof of the building. So connecting all of that with the vision, so we can achieve the 2030 vision, or the purpose of the vision, and we can also go beyond. So we reduce the energy consumption of the building, reduce the CO2 emission reduction, or reduce the CO2 emission, and also saving money and water as well. So since buildings in Saudi Arabia are like school buildings in Saudi Arabia are the same, so taking just Mecca city, which has 700 schools, if we implement it or if we achieve net zero just in Mecca schools, we can reduce the CO2 emission by 275,000 metric ton. And to have an idea how to understand this number is that 275,000 metric ton, which can be produced from having inefficient buildings, inefficient school buildings in 1 year, can replace it or can take it back from the atmosphere. If we want to take it back from the atmosphere, we need 275,000 trees, and 40 years in just taking the CO2 emissions that was produced in 1 year. So after all of that, in my project or in my case study, I just took a school as a case study, but this study can be also implemented for different sectors. So it's not just for school building; it can also be implemented for commercial building, residential building, which has the highest energy consumption in the country. Thank you so much.
First, I'm impressed by what you've accomplished. I mean, the level of accuracy and granularity with which you discuss the issues with the building is really impressive compared to where you started. So I congratulate you on the amount of knowledge you've assimilated and have become an expert upon in a short period of time. I think you did a really nice job presenting the issues with the building, talking about them, the conduction, the radiation issues through the envelope and how to improve it. Really nice, very well done. I want to thank you for your vision statement. I liked your goal, that you had a goal for the project. It made very clear what you're trying to accomplish. And I think that helped you map out how to do that, because you knew what you were trying to accomplish, but then you need to figure out what are the factors that affect that, how do I get there, how do I accomplish this goal. So I think that really helped, focus the audience's mind about what you were working on and how you did it. But I think, just how articulate you become on the issues of energy consumption in buildings is very impressive. Thank you so much. Very nice work.
Thank you. Totally. The nice thing about your work is that it actually conforms 100% to the country's vision. And since this is a 2030 vision, it seems like there is a component here that can actually start to initiate some efforts in Saudi Arabia, particularly in your region in Mecca, to begin to reach to that goal. Very interesting and very complete work. The whole thing is so convincing. You started with making a reference to the typical performance of these schools. I would want to ask you, where do you take it from there? Because this is so important. And the country needs people like you when you go back. So who are you going to be talking to? Who would you address these issues? They're not going to happen. It's easy to happen in academia, but then once it gets to implementation, there is so many layers of politics and that you have to
Yeah.
fight your fight. So who are you going to be?
So like before I chose like or before I chose to be working on schools building, I was planning to work on a residential building. But after meeting the architect of the Ministry of Education, so I remember that I went to his office. I was sitting in his office, and he has like a really huge or big office that have like around maybe 8 windows, and all of them were blocked. When I was talking to him and he talked to me about the intention of the school or like the government to enhance the building performance, he told me like, as you can see, I'm sitting in an area and it's like a daytime, and I'm not using any of the windows to provide daylighting, and this is what the intention of the government to enhance the performance. I told him, okay, what government, like what is the step that government took to achieve this? And he said like, this is what we did, like we hired like a company that work on enhancing the performance of buildings in Saudi Arabia. So what they did right now is just changing all windows in 1 year. The result that they got from 1 year, they replaced all the windows with a double glazing window. And this is, I told them like, any other step that they taken, they said like, okay, this is what they did so far. So my plan is to take my project and to go to the company and to provide them the proposal that I have for enhancing the performance of the building. They might accept it, and like since they already have a vision or they already have intention to change the performance, they might accept it. Like they might see or take some ideas or like recommendations about how to enhance the performance of the building.
Perfect. And you would probably work with them.
Yeah.
And if I assuming that, how about the government itself? The people who finance this, the people who charges that office.
Yeah, like I remember the last time when I went to the field trip, the architect over there, he told me that government, like the Ministry of Education, they started like achieving zero in school and not in existing school, in a new school. So I think they built one school in Riyadh, a net zero school in Riyadh. So they have this vision or they have this idea. So I might like if I go to them, they will like accept it since like it's a big issue right now in Saudi Arabia to enhance the performance of building. So I think they might like
but when they see this work, because this is like a method
yeah.
on how to do it. It's like you providing a roadmap for them, and they have not seen that. So they're not expecting that maybe they think you have a story, but you actually have a method. And I encourage you to advocate for public presentation, and that would be attended by those government personnel, and maybe a couple of publications in major publications. I would make a big wave because that's exactly showing them how to do it. Of course, the one thing you need to add to that is how you can adapt this method to other building sectors, like the residential or maybe to hospitals or what have you. But you need to show that this.
Well, he has that diagram at the very beginning that showed like the 9 steps.
Right.
Analysis.
Yeah, absolutely.
That's like sort of the roadmap that would be useful. I think like, can you go to that section cutaway view of the building that shows
the strategies?
Well, you showed it a couple, like that guy right there. Like I think that's a very useful image that can really sell what you're proposing for them. Because what's nice is it's a pretty grim building, and you've made these dramatic improvements without really changing the appearance of the building.
Yeah.
So I mean, I'm pretty astounded that you've been able to save this much energy just by improving the envelope and improving the windows, because the building itself is not a fantastic building, but you've done something nice with it. I think it'd be useful though to see the PV array, because that's 230 panels is pretty big. It's probably going to extend beyond the roof and maybe shade the walls, and could have a potential to have a nice
I think
There are like further like strategies that can be implemented, but what I try to do is to implement strategies that can be implemented very fast, like as a one step toward achieving net zero. So if we go further, we can implement also another strategies, cool tower, and other strategies that can enhance the performance of the building even more. We can like get to a reduction of 80%, not just 60%. So we reduce the need of PV panels as well.
I guess I'd also like to see like a picture of the Mashrabiyah on the east and the west facade, like what it looks like from outside the building. I think that'd be really useful because I think it would actually enhance the architecture of the building and make the performance better. And I think, I mean, you're gonna need some attractive images to.
Yeah, I have some images, but like I was trying to render it and have
Did
some
that
rendering
photo,
with it.
did your sister took that photo for you?
The picture is it's not like I didn't know that I used I used the button for the Mashrabiyah, and I didn't know that, like, and I was checking my sister's Instagram Snapchat, and I saw the exact same button that I used. I thought, like, I asked her, like, can you take more pictures of it? This one is.
Okay, before you leave that, before you leave that slide that called you, I wanna just to make a quick remark here. You were talking about do a night ventilation to flush off the built-up heat and all of that stuff. And the way how you stated looks like it's narrative, but in fact, your computer simulation showed when to open and close the window, at what time, and in which month, and how is that controlled? Did you control it like through sensors, or do you control it manually? So I think there is a whole, So there is a whole layer of information that is not shown actually on this slide. That is way much more detailed to every little tiny detail on how we can actually achieve that. Because that's your, and then the shading. We talk about the shading. You resize the shading. You should have those dimensions specified.
I have the dimensions and everything. I have it in the documents, but like
I know. But what I'm saying is, it's not as general as this. There is a whole.
Totally, it's not.
Like you can generate a whole document based on this just one slide on how to achieve those.
Yeah. So even my observation was the same. Like I would be more interested in seeing your simulation process and more information on that, like what exactly manipulated and changed and what those changes are. It'd be great to see that in the presentation. Also, I was wondering if that screen, the Mashrabiyah, could be accurately modeled, and if you model it accurately, does the program read it correctly, like the percentage of openings? Is it able to do an accurate job of that?
Yeah.
I choose the.
Well, you put a screen over it and you give it percent open.
Okay. So, but
you're not modeling Mashrabiyah per se.
But you figure out the percentage. Okay.
I choose a Velux software, which like you can just take the building from SketchUp and put it in Velux, and it can simulate the daylight and sunlight and everything.
Yeah, but not the heat energy and the radiation stuff, which I think the percentage of opening is really vital, especially when you're talking about the east and west facades. And so if you mention that percentage of opening and just
You
talk
specify
about
not just the percent of opening, even the translucency of the opaque surface and the reflectance value of that surface. This is a great presentation. Sohaib, on slide number 6, I think your definition of needs to be in 1 year. That has to be in 1 year. So it produces as much as it consumes in 1 year. It has to put the 1 year. And then we talked about slide 30, who will control the natural ventilation. You need to have been a little bit more specific, because I think you just asked the computer to do it, and so you should extend that vision. Who do you think? Is this the building managers? who would be there at night to do it? Or?
There is a gardener that, like he has a room in the school and he stayed there. Like he works in the room. He works like in the building and he stayed there all the time. He even have like a space for his family to stay there too. So in every school they have like a building or like small building that connected to the school that have like a gardener that he is responsible for like shutting off all the HVAC systems and open the windows and everything.
Okay. But from what time to what time? And then
You have to specify
and all
that. I have to
stuff,
specify that.
remember,
You better have a
And even
building.
I can make it like
Buildings.
mechanically or
It'd
something.
be nice to have a
that
building
can be
control
open and just, like
system.
set up of time.
So you do it naturally, not actually by using just a mechanical
Motorized.
ventilation. Natural.
Yeah.
This is excellent work. Do we have any comments from the audience?
I have a few quick comments. I think you really did a good job. Sorry I walked in late, so I just sat in the back really not to disrupt the room. But I really like your presentation. It's very clear, very straightforward. I know you did a lot of effort. I agree with Altaf and Professor Shalfoun that you did a lot of effort in your e-quest. I know that you had quite a bit of a struggle working on the file and you kept persistent on working on it. So I think more of that, not the persistency part, but more of the work that went into the e-quest would be really nice to show because it proves the portion of the performance of the building and how it happened, what are the details behind that. I think that would be an important piece to add. I'd also recommend when you go talk to the school that you don't use this as like your end product, but rather that this is
Step one.
Sorry?
A step one, like a step one.
Yeah, so your understanding of energy and its application to the building is a tool that could lead the school to better locations or
Yeah.
better, when they save $46,000 a year, this is money that can go towards other programs or could fund activities or could do other things that would take the school to a better place. I think this is something that would be very interesting to the school, opportunities of things that they can start creating because now they have more funding that's available and that could something that would enhance the students' education, whether there's like funded programs on energy or anything like that that would serve the bigger purpose of your vision. And I would also recommend that you be specific about where the vision doesn't state the energy reduction part. The vision is more focused on the energy generation part.
Exactly.
By creating solar farms, off